Okay, how's it going? So Friday class was canceled, right? So the TAs were supposed to teach that class, and it was supposed to be like a more fun class going over style guides, and you were going to take a quiz. So we're actually going to move that to this Friday. So the quiz this Friday will be over for loops and lists. And then in next week you have a fall break, remember? So originally I wasn't going to have you all have a quiz that week, but because we're shifting things over, you will have a quiz next Friday, which I think actually works out better because given Labor Day, having a class canceled, shifting things over, it makes sense because I want the quiz to be a review of what you learned the previous week anyway, so you could do the homework, learn everything, have it all settle in your brain, and then take the quiz. So I think this is actually better. So just a reminder, you will have a quiz this Friday for loops and lists. And then next Friday, the quiz will be over 2D lists, which is what we're talking about this week. Make sense? So the TAs will still teach the class on Friday. I will still be present for most of it, but initially, they were just going to do all themselves. Hi, Bryce. Good morning. Okay, so let's talk about 2D lists because we're going to do that in your labs tomorrow. So,
Oh, sorry.
yes, you.
So we're not having a quiz today.
No quiz today, so it's Friday instead. Yeah.
Last week's stuff.
So last Friday is now going to be this Friday. Yeah, initially I wanted it to be Monday, but because I don't want to fall too behind and there's a lab tomorrow, we're going to talk about 2D lists today so that you can practice that during the lab tomorrow. Make sense?
Thank you.
Okay. So thank you for being patient. Hopefully it was a good break, but also you were safe and dry this weekend. Okay, so we're going to do a recap of lists. Then we're going to talk about 2D lists. And like I just said, the style guide lecture, that's a more fun lecture, is going to be moved to Friday. TAs are still going to do it. And then the quiz that was supposed to be then will also be Friday. Okay, so recap. Lists, what are they? A data structure that allows you to store elements in order. So these elements can be strings, numbers, other lists that we're going to see today, and even other data structures that we'll learn later on. It's a data type itself, so remember the data types you've seen before, string, integer, boolean, float. Remember those are immutable. Once you create them, you can't change them, but with lists, you can change them. And we'll do a review of that too. So remember we can use the length operator, index into them, slice lists, use the in operator, concatenate them, and iterate over them, traverse over them. And why are they important? Well, if we want to have our data represented in some way, if we want to maintain the order, then it makes sense to use a list. And we'll see how we can also use 2D lists to represent data. And then recall from last week, we can change lists using built-in functions you see here. So append, extend, insert, remove, and pop. Okay, so again, mutability. If it's considered mutable in Python, once you create it, you can change those values. Otherwise, immutable types, once they're created, those values cannot be changed. So immutable types include integers, floats, booleans, and strings. Once you create them, that's just how they are. You can't really change them. You can have a variable assigned and storing different types, but the type itself of that data value is not going to change. You can't change it. But lists, once you create lists and define a list, you can then mutate them and change the elements inside them. So they are considered mutable data types. Make sense? So mutating a list, we've seen these things. We can update an item in a list by using this syntax. So my list, specifying the index of the thing you want to replace and change, and then telling the computer the new value you want to be in that position. If you wanted to add items to a list, you can use .append, which is just adding a value to the end of the list. And you're passing in as a value to the function append the value that you want to append to the end of the list. You can also use insert, where you specify the index that you want the new value to be in. You can also extend a list by passing in an argument that's actually a list itself, remember? And then .pop, .remove. These things, these built-in functions will remove elements from your list. Okay, so I have this list of Pokemon that has these strings, right? So after each of these lines are run, tell me what you think Pokemon now stores. So if we say Pokemon 3 is now equal to Ivysaur, the list will be updated, and which element is going to be affected?
No, sorry, Bulbasaur.
Bulbasaur, right? So now we're replacing Bulbasaur with Ivysaur. If we want to say Pokemon.append Pidgey, now my list will have an extra thing at the end, right? So now Pidgey will go at the end. Pokemon.pop, think about it. It's popping and removing that first thing, right? So now Pikachu is gone, right? If you do Pokemon.pop with nothing in it, where does it take it away from in the list? The end, right? So now Pidgey is gone, right? Now we're going to insert Wartortle, I don't know, into the list at position 2, right? So you count to 2, 0, 1, 2, Ivysaur, and you're putting it in front of Ivysaur because now the new position of Wartortle is now 2. So now Wartortle is in 2, and that's where we specified with index. Yeah, Zio, do you have a question?
Yeah, my question is with the pop.
Yeah.
Yeah, so, although I didn't really check it, I thought that what would be returned would be what is removed.
Yeah, so what is returned to that function call is the element that you removed. But it still mutates the list, remember?
Okay.
So .pop will both mutate the list and return the element that it removed. So if you just called it like that, that's fine, because it mutates the list. If you wanted to assign it to a variable, then you're storing that element that you removed into that variable.
Okay.
Make sense?
Yes. Yes.
So if I had like, I'm just going to type here, like something is equal to that, then what do we pop here, right? Charmander. We popped this one off. Oh wait, no, sorry, we popped the last one off. We popped the last one off Ivysaur. So Ivysaur is stored in something now. Make sense? Yeah.
Let's finish this one.
Oh, finish this? Okay, let's finish and then Daniel, I'll get your question. Okay, so now we're removing Squirtle, right? So we see Squirtles in our list. So now the list has those 3 things without Squirtle, right? And then if we said Pokemon.extend Charmeleon, then we're going to add that one to the end of our list, right? But it's not making another list inside, right? Because extend takes in a list as a parameter. Make sense? Pokemon.remove Charizard. What's going to happen? Error, right? Value error, because it doesn't see it in the list, and that's just how this built-in function behaves. Remove is going to error if it doesn't see the value you want to remove from the list in there. Okay, Daniel, what was your question?
My guess doesn't make sense.
It's been answered? Okay. Okay, any questions on this?
Thank you.
Yeah, no worries.
Very, very quick, Jack.
Yeah.
So when you assign those pop to let's say variable,
Yeah.
it's actually the variable. What's stored in the variable is what's is pop. It's
The
what's
element that removed,
Yeah,
exactly. Yeah, what was popped off
Yeah.
the list.
But then if after those pop, you call them Pokemon, for example, the complete list without the element that was popped.
Yeah, if you printed Pokemon, then the pop method would have mutated that list. It's changed it now, right? So then it would have that element gone. Yeah, exactly. The list without that element.
Thank you.
Yeah, good clarifying question. That's exactly how .pop works. It mutates the list and it returns the thing you removed. Yeah, Daniel.
So now for extend takes takes a list.
Yeah, takes in a list and then it'll extend the list that you called it on with the elements inside that list.
Well, append does not take the property.
Yeah, append will just take whatever you passed in and put it as the last element.
So
Yeah.
that's why you can't have a list inside.
Yeah, exactly. So we're actually going to see this again. So just to reiterate, there's a difference between accessing elements and getting information versus changing the list. So in the left hand side, this box, states would be the same. After each of these operations, if you were to print states, it would be the same as what it was initially. Okay? But then on this side, the right hand side, this box, all of these built-in methods that you call are going to change states. So states is actually going to change after each of these lines of code. Make sense?
Yes.
Okay. So let's talk about 2D lists, and we'll start off with the example that Daniel is talking about right now, just to refresh your brain. So remember this slide, right? We had companies is an empty list, and we're extending it by these two things. So now companies is a list with these two things, right? Then we want to extend it by 3 more things. We pass in a list into extend, and then the result is that one list we start off with companies with the elements inside extended. If we were to append a list, now what Daniel was saying, right? We take whatever we pass in to append and we just plop it in as the last thing in this list. So now we have a list with a nested list, which is like a 2-dimensional list, right? So if we were to access elements in our list, be very careful, right? When you see nested lists. So what is companies 5? 0, 1, 2, 3, 4, 5. What is it? What is the data type of companies 5? A list, right? And it's that element, right? So Microsoft and Lyft. And then company 6, what is that? Index error, right? You see your list companies and you're trying to access something that isn't there. So index out of bounds, that thing doesn't exist. There's no such thing as a 6th element. Okay, now let's do companies 5 and then index into that further. Yeah, so nice, you got it. We take this list, right, which is companies 5, and then we take the 0th element within this list, which you all just said was Microsoft. So it's a string, Microsoft. Companies 5-1, which one is it? Yeah, the string, and it's Lyft. And then what is this? Yeah, so now within this list, we're going out of bounds. There's nothing there, index error. And then what about this one? So companies 5 is this, and then 1, remember we said was Lyft. Now we can index into that string, right? Totally valid. So what character is in the second position? F, right? 0, 1, 2, it's F. Yeah, so now we can get the string too, right? Then if we index further into this, probably wouldn't work, right? Because now it's a string. Or it would be an index out of bounds error if you tried to index something further. But you could further index into the string. Okay, makes sense? Okay. So 2-dimensional lists. A 2D list is just a list of lists. So an example of this would be this list with sublists as A, B, C, and X, Y, Z. You can access the inner list by indexing, right? We just saw this. So if I wanted to get the first list, I would say my 2D list at the 0th position is ABC, right? The list with these 3 strings. And then you can access the inner list values, so values within this list, by then indexing into that list, right? And we just saw this. Now we have 2 indices, right? So we have my 2D list. The first element is a list itself. And then if we wanted to get values in this list, we could index into it, just as normal, right? Indexing into a list. So all of the stuff we've seen before, it's just in a different way, because now we have lists inside of lists. Okay, any questions? So what can we do with 2D lists? Well, we can literally represent grids, like with our tic-tac-toe. We can represent that as a grid. So lists of outer lists will represent a row, right? And then each value of the inner list will represent a value for the column. So you can think of a 2D list as a grid with these positions. So 0, 0, 0, 1, 0, 2, right? This is a row and this is a column represented by our list. So just to be more clear with this slide and show you, just in case that's confusing. So this is just a function that'll print it for you. You can ignore that. But let's say we wanted to make a grid of this size, so size 3. And my grid is going to be represented as a list of lists. So I start off with one list and I'm going to add lists inside. So to create the rows, what I'm doing is I'm appending this many rows inside my grid. So if I were to print this, let's see what it looks like. Okay, so I have a list, right? And inside my lists are more lists that have empty things right now. Row 0, row 1, and row 2. Does that make sense? So the first thing in your 2D list is the 0th row you can think of. The first row, that is index 0. Okay?
So it's good.
Yeah.
Can you repeat?
Yeah. So remember, a grid is like a list of lists. So what I'm doing right now is creating a way that you can kind of visualize it. So right now, I have a list with empty lists. So I currently have 3 rows with nothing inside them. Row 0, row 1, and row 2. I've built out my rows, but let me build out the columns and show you as well. Maybe it'll make more sense. So you can kind of ignore this code for now, but what I'm saying is for each of my rows, I want to give it 3 columns too, right? Because I want a 3 by 3 grid. So I'm just iterating from 0 to 2, range size, right? Because my size is set to 3. And then let me show you what this looks like. Okay, so I have an outer list. This is my grid. And then each of these inner lists you can think of as a row. Okay, so row 0 is this first one. Row 1 is this next row. Row 2 is this next row. Then each of those rows, I'm giving it a column. So column 0, column 1, column 2, right? So this grid, this 2D list is 3 by 3. Does that make sense? So let me show you in another way how we can try to visualize this. So if I wanted to show you the coordinates, like what this graph was representing, right? And I print this, these are the coordinates now, right? So 0, 0, 0, 1, 0, 2, because it's row 0, column 0, 1, 2. So see the row index here, 0, 1, 2, 0, 1, 2, 0, 1, 2. And then the column index, right? Zeros, all ones, all twos. Does this make sense?
Yes.
Yeah, Sadiksha.
So in the nested lists,
Yeah.
the lists
Themselves are rows. You can
the
think of those
inner
as
lists
rows.
were separated by commas.
Yes, yeah.
So where are they?
I'm pre-printing it to visualize it. If I didn't print it like that, it's a little bit harder to visualize. So now it looks like this, right? So this is technically what the code looks like if I were to print the grid. But I just wanted to try to help you visualize it, so I created this method that just printed a little bit nicer, right? So yeah, you're right. The commas are supposed to be there. Yeah.
Oh, yeah. That's.
This is just to help you visualize it, yeah.
Oh. So
But I
is
could
it-
add
is
the
this like
column.
you have to import this.
What do you mean
Define-
import this?
okay.
I defined it, yeah.
You created a function.
Yeah, it's just a really silly function. But yeah, now I'm adding the comments, right? Okay. Yeah. But that's just a thing that I'm adding. Okay, so does this make sense? Every list inside of your 2D list you can think of as a row. Then each of those values inside this would be like the column, right? So 0, 0, 1, 2, these are the rows. And then each value inside, this is the 0th column, first column, second column. Okay, so that's what this slide means, really. Okay, makes sense? Okay, so these are grids we've seen, right? Crosswords, 2048 games, Sudoku, this, I don't even know what this is called anymore, dabbing unicorn or whatever. Yeah, these things in the back end are all probably represented using 2D arrays, 2D lists, right? These are all probably built with 2D lists if you would have an electronic version of this game. So, for example, Candy Crush, how do we keep track of which symbol is in each cell of a grid? Well, that would probably look like this. If we took this little part of a grid and represented this data, right? With a data structure in code, this is what it would look like, right? A list with lists inside, each representing the position that it's on in this grid. right? So we have coordinates, right, like this. Those coordinates represent kind of where this information is, right? Do you see how this grid became this 2D list? Make sense? Okay. So let's try to have another application of a 2D list. So databases. A database is just a collection of organized information that you can easily access and manage with different configurations and add and update information all the time, right? So with Yelp, there's probably a huge database, right, of like your reviews and the different information that you would apply to like a restaurant, like its hours. Like remember, you can see if there's like free Wi-Fi or there's parking or it's friendly for kids, stuff like that, right? All of that information is organized in a database. Also BuzzFeed organizes information for us too, right? All these links, all the information that you see on the page, probably stored in some database. If I were to search stuff in like any search bar, right? Or I guess in Google Maps or whatever this information is all going to be stored in a way that's easily organized so that you can access this information. It's not going to be all over the place, right? This is why it's so important to like know the data that you have and how you want to represent it in a way using the proper data structures that make sense, right? That's all problem solving is in computer science. So another example, IMDb. I actually didn't even realize that IMDb stands for Internet Movie Database, right? So this is another example of a database that we've probably used before. So let's look at what a database might look like practically. Like if you had a application that was a database, it would have a GUI, right? That would show you stuff like this. It would show you a table. And each of these rows is considered a record in your database with this information. Okay, so in this case, I have different songs, and each of these songs have like an artist, a title, an album release, your genre, right? Those are considered the fields of each record in a database. So if you were to go on and do more computer science stuff, you would learn more about databases and how they're structured, how you can efficiently access information, right? But for now, you can think of a database as like a table of information where each row is a record of information that gives you each of these fields too. So we can have essentially a database stored as a nested list in our really simple example of information, right? So we could convert this into a 2D list that effectively can be our database, right? This is a valid database, right? How we get information, how we access information, all of that is we can do, right? And that's what a database is. So we have our songs, and each row, right, each record in our table corresponds to a list, right? So the first song is our first row, which is our first list inside of this 2D list. So just like lists, you can index into 2D lists. So all list functions that we've learned work for 2D lists, right? Because they are just lists themselves. So when we index into a 2D list, the first index is the outer list, and then you can then index into those lists to get those values, right? So the outer list is like your database. The inner lists inside are like your records, and then within those records are your values, right? And you can index into them to get that information. So if we had our songs list like this, or our songs database rather, right? Song, we want to have that store what songs 3 is. So the third song in this list. So 0, 1, 2, 3, 4. Songs 3 is this entire list, right? So indexing into this 2D list with the first index will give you a list. Then if we further index it into 0, right? Songs 3, the 0th element is this string, right? So that's how we get that value, right? And then if we flipped it, let's say we wanted the first song, the 0th song, I guess, and then the third thing in there. We go to 0, and then we go to the third thing, right?
Yes.
Does this make sense? Yeah, Zio.
My question is this still regarded as a 2D list?
Yes.
If it's a nested list but it's on the same line?
Yeah, so if all of this looked like it was on the same line, it would still be a 2D list, right? This just makes it look nicer for you to process what's going on. Yeah.
So how did you create like line by line?
You could. There's probably built-in methods you could do, but I like forced that. But you can't actually. The computer's not going to print it like that for you. You have to like use other tools to do that. Yeah. Yeah. So it can be tricky. It can be really tricky to work with these because it's really hard to visualize it sometimes, right? You have so many things, so much data everywhere. That's the tricky part of it, right? Is making sure you're not messing up with the indices and stuff. But I bet you could figure out a way that you could print it nicer. Yeah. Yeah, no, that's a good question. Yeah, so there's no built-in way to do it, but you could find ways to help your brain process the information. Okay, so let me just check time really quick. Okay, so songs 4, 2. So we go to 4 first, right? And then 2 is this one, right? So 2019, 0, 1, 2. Okay, and then what is this one now?
What? Songs 5. Index.
Right, you're trying to access something that's not there, index error, right? So same thing. Same things that apply to lists will apply to 2D lists. Okay, songs 1, 4, what is it?
Index zero.
Index error.
Yeah, also index error, right? We go to 1, but there's no thing there that's 4, so index error, right? Okay, so just like lists, we can iterate over 2D lists. So let's say we wanted to iterate over this list of songs, this database of songs, and we wanted to print everything, right? We could do this, right? So for each song in songs, we're taking that list and then we're indexing into it and printing that information assigned to its like field, right? The column value,
Oh.
right? So just to trace it, let's do it. For the first song, right? Print song plus song 0. Song 0 is circles, right? So it prints that. The next thing is the artist, right? Because now we're in this line, right? Artist plus song 1. This is song 1. And then now it prints year. And then the genre, right? And then a new line. Then we go to the next one, right? The next song, because we're going into the next iteration of the for loop. Yeah.
The string that you put there.
Yeah. Where?
Like because this is because of the like that type was 2019. Was
Yeah.
integer.
It's an integer, yes. You have to cast as a string, right? To concatenate them.
You have to concatenate that.
Yeah. Okay, so is everyone following this? Does this make sense?
Yes.
So when we go to the next song, then we do all these things again, right? We're repeating code. The power of a for loop, right? Allows us to repeat code, rerun it, but without duplicating it. So now we've done it for all the 3 songs in this database, right? This database, which is essentially a 2D list. Okay. So what were we iterating through, right? We iterated through these songs. We traversed the songs, which are the rows in our database, right? But then it kind of looked like we were also traversing each of these rows too, right? For each of these rows, we were going through each of them and looking at them, right? So we were also traversing the values, which are the columns in our database, right? So if we want to visit each thing in this 2D list, we can traverse it using nested for loops. Okay? Yeah, Daniel.
But is that why you song into brackets?
Yeah, so song, what is the data type of song?
No,
This
like,
song.
I mean, like the song is represents like the rules.
Yeah. So this song is a 2D list, right? It's a list with lists inside.
Yes. I know that the songs is like as like a list inside the list, but like I mean
Yeah.
like for like is that usually for like song open brackets you're like representing that for whenever you go to a particular row, the index 0 should print something.
No, so, okay, so I don't know if I understand your question, but let me just repeat. So songs is a list of lists, right? So when you're saying for song and songs, each of these
Yeah.
is a list itself,
Yeah.
right? And then you can index into that because it's a list, and that's a valid thing to do. Yeah. Does that answer your question?
Yeah,
I don't know if I actually got your question. Okay, so just to repeat this, if we wanted to go to each thing in here, we could use a nested for loop because we're traversing through all of the things in our first list, which are all of our rows. And if we wanted to go through everything in our row, we would do another loop, right? Which is totally fine. Nested for loop.
For something.
Yeah, exactly. So an example, a nested loop, it's just a loop inside of a loop, right? So usually you will have nested for loops. You could have while loops inside while loops and for loops inside while loops and one while loop, for loops, whatever. But usually you would have this pattern, right? For and then another for. So if we had for I in range 4, print I, and then for j in range 3, print I and j, so print this string concatenation. Think about what it would do. Okay, so take like 10 seconds, think about it, and then we'll trace it kind of together. Okay, so if we were to trace, I'll give you some more time. I think we're good on time. Okay, let's talk about it. So first we see the for I in range 4, right?
Yeah.
So you know it's going to be like 0, 1, 2, 3,
Yes,
right?
yeah.
So print I, it's going to print 0.
Yes.
Then it goes into this next loop, right?
Yeah.
And then it prints I, which is 0.
So it's gonna be 0.
And then J, which is 0. Because J is going from 0, 1, 2, right? So then 0, 1, 2. Because we loop that first.
We're not going to the next one.
Yeah. So we do that inner loop first, right? Finish that, and then go back and do the outer loop. So it's like we're going out, doing this a bunch of times, how many times, going back out because we're doing that again. Nested, right? So in, looping, go back, loop, that's another loop, right? So then I is 1, and then we loop through the inner loop, right? 0, 1, 2. Then I is 2, 0, 1, 2, right? I is 3, last one, right? 0, 1, 2. And then we're done. Make sense?
Yes.
Okay. So if we were to trace this example, right? Let's say we now have this 2D list, this board, that's like 2 by 3 or 3 by 2. So for row in range 0 to length of board, then we go into our nested loop, right? For column in range 0 to the length of board, right? Print what was in there, right? So row is 0, column is 0, right? Row 0, column is 0. So you're indexing into board that many times. So 0 first, 0 thing, this 0, and then the next 0 is 2. Make sense? Okay, so then now we iterate again in this inner loop. Column now has 1. So now we print the value that's in this position, right? The 0, 1 position. We've finished this inner loop, so now nothing left in this range, right? We finished this inner loop. Now we go to the next one, right? So now we're in this outer loop. And now we're doing this inner loop again, right? And that's iterating through all of these values. So 7 and then 2, right? Nothing left. Now we go back to the outer loop, right? Because we finished iterating that inner one. Go to the outer one, now it's 8 and 5, right? So now we print 8. Now column is 1. Print 5. There's nothing left. We go out here, there's nothing left here either, right? So then we're done. And now we've visited everything in there. Okay, any questions on this? Deal, yeah.
Was there any reason we put 0 there in the range?
Yeah, why do you think we put it there? Think like, what if it was a 1? What would change that?
I think he meant we should have just skipped 0.
Oh! Yeah, you didn't need to put it there.
Okay.
It could be omitted if you wanted to. Yeah.
Yeah.
I thought you were asking why does it have to be 0? Okay, yeah. Yeah, so you could, not have it, because range without that first argument would implicitly start at 0. Yeah. Okay, any other questions? Does this make sense? Okay, so what I want you to do now is take this code and write it to be a nested for loop that does the same thing. Okay, so if you go to the Colab, you have this code, right? And we already saw it does this, prints each of these songs like this. Now try to convert that to be a nested loop. That's doing the same thing as what it was doing in this here. Does that exercise make sense?
Yes.
Okay. I'll give you like 5 minutes. I'll play music.
What?
Huh?
What is it?
Go to the collab.
Okay.
Go to the collab and make this into a nested loop instead of one single loop. So convert this
Yeah.
to using a nested for loop. Make sense? So you see how it's not a nested
Okay, and
loop?
then
Yeah, go to the collab and do it, and I'm gonna play music.
Okay, thank you.
Once I find where my music went. Okay.
You are not hidden.
Would you like this?
Never been a moment you were forgotten. You are not hopeless. You have been broken. You're stolen. I hear you whisper underneath I hear your send out an army night is true. I will rescue. There is no distance cannot be covered over and over. You're not defenseless. I'll be a shelter. I'll be your armor. I hear you whisper underneath your breath. I hear your rest, your I hear you whisper you have nothing.
What's this?
Send out an army to find
Do you have your phone?
in the middle of the
Do you have the book?
night.
Do you have the book? Like, do you book one? What was it? No, that's not it. This one. Just go on asking. Oh, well, I'll find it.
Oh, I will rescue you.
The question is, oh my god, like this is what everyone does. Which means exactly.
सूरज जैसे चमकेंगे देखे है साथी अखियां ने है सपने अमराते ए सपने अमराते बूंद बूंद जोड़ेंगे पल पल दूर दूर बह जाएंगे फिर ना समझ राधे फिर ना समझ राधे ऐसी ऐसे खड़े है जाना पड़े ना तुम हमको छोड़ ऐसी सिद्धते हरे जुनूनी बड़े ऐ दिल के नमों एक जिंदगी मेरी समाइशा एक तुम्हें पूरी करा एक जिंदगी मेरी समाइशा
And just know that
तुम्हें पूरी करा एक जिंदगी मेरी समाइशा मुश्किल हमें रोकना शहरों जैसे बन जाएंगे हम तेरे जो छोटे छोटे रस्ते गलियां दे ऐ रस्ते गलियां दे बबलू की तरह महकेंगे हौले हौले यारो एक दिन मौसम गलियां दे ऐ मौसम गलियां दे अभी ना जाने कोई है क्या अपना ऐसी सिद्धते हरे जुनूनी बड़े ऐ दिल के नमों एक जिंदगी मेरी समाइशा एक तुम्हें पूरी करा एक जिंदगी मेरी समाइशा एक तुम्हें पूरी करा एक जिंदगी मेरी समाइशा मुश्किल हमें रोकना रात है कजले वाली दूर बड़ी दीवाली दीवे ढूंढे अखियां दिल वाले घोंसले में पंछी बना के यारो हमने उम्मीदा रखियां मैंने हार ना डरी है
Okay, hopefully that was enough time. Okay, so I think for the sake of time, why don't I just show you kind of what your solution should kind of look like. So if you take a look at the screen, what I did was created a separate like fields array that stored this. You could have done it a different way, right? But this is how I did it. And you could have had this be like the first thing in here too if you wanted. It's you could do it however you wanted to, right? But what I did is where I arranged the songs, set my song to be the first thing, and then iterate from that range of the length of this song, and then print these things, right? So print fields with that index, song with that index, make sure I cast as a string. It does the same thing as the code here, right? But with the single loop. Okay, let me show this again. So again, you could have done it a different way. You could have had this be your first row, range from 1 to whatever. I don't know if that's making sense, but does this make sense?
Yes.
Okay, I'll try to create another solution as an alternative and you can see the differences. Okay, so just to wrap things up, 2D lists, they are a list of lists, right? But it is really just a list at the end of the day. So you can use all the functions that we learned for normal lists, single level lists, I guess, 1D lists, on 2D lists because they're also lists. So you can index into them, you can iterate through them, and a 2D list is just essentially our database, right? It holds data in a particular order, and each item, each row could have many elements in there, right? And then a database is just a collection of organized information to be easily accessed, managed, or updated. 2D lists, actually a valid database, right? When you go off and do stuff with more complicated data, you're gonna have different frameworks that help you manage databases. But for now, this is a way of learning your first simple database, right? 2D list. Okay. Any questions? Okay, so reminders. Project 1, Part 5, I released it this morning. So now you're actually going to write your unit tests and integration tests. You should have been thinking through all these cases for Parts 3 and 4, right? But now you're actually going to write them. So you have a week to do it, due on Sunday. Homework 5 is due this Wednesday, and this homework, remember, covers for loops. And then quiz 5, reminder, is this Friday. So bring your laptops, and then this will cover for loops and lists. Reminder, midterm exam 1 corrections, they're due October 8th at 11:59 p.m. So you can follow the instructions here, and I just want to show you all the doc. So really read these instructions carefully, okay? I updated it a little bit too. So just see the newest version. But what you're going to do is make a copy of this and type in all your responses like in these boxes. And I really need you all to follow the instructions here of sharing it with me. So you're going to hit share, and then you are going to say anyone with a link and then can comment, okay? So all of these instructions are here, and then you're going to email me that link, okay? So email me this link. So that way when I'm grading with the TAs, we're going to comment in the doc if you had a good explanation and a bad or needs improvement one or like an okay one. And then that will determine how many points you earn back on your midterm, okay? So if this is not something you've done before, it's fine. You're gonna learn because I do this every day, all the time in my real job. So you might as well learn the skill now, right? How to use Google Docs and how to comment, how to see comments, how to interact with this workplace thing. I don't know, productivity tool, whatever it's called. Because you're going to use it, I guarantee it, in your life. So might as well learn how to do it now. Okay? So follow the instructions carefully. Yeah, Monica, you're good.
Do we write the answers and more explanation for that?
So you will follow the instructions, right? Write a 1 to 2 sentence explanation for how you should think through the problem to lead you to the correct answer. So if you missed this one, for example, you would type your explanation here.
Only for the
Of just the explanation. So you already have access to the right answers, right? So think about why that answer was right, and then think about next time how you would get to that right answer. Yeah, Dola.
We're only writing explanation for the ones you missed, not everything, right?
Yeah, only for the ones you missed. Yeah. Because you already got full credit on the ones you got, right? Okay, any other questions on this? Okay, so last reminders, you can see your grades. If there's anything that you think is wrong, let me know, because I'm human, I make mistakes. Maybe I graded it incorrectly. And then I'll update my records just to make sure you got the grade that you deserved. So just let me know. And last thing, Google TAs. STEP opened, right? So I'll actually add that as a slide, I think. Yeah, so STEP applications. Oh, but maybe it hasn't opened for real. I don't know. They opened today at some point today. Not yet. Oh, it has. Oh, it has. Okay, so it's opened. So apply, right? The earlier you do it, the better, right? Oh my gosh, I just touched this thing. And everyone should apply, right? Even if you think it's not going to be for you, whatever, just apply, because you can say no to them, right? But if you don't even apply, you don't get that chance. Okay. Any questions? Yeah, Prashesh.
So where are the right answers for the midterm?
Oh, yeah, good question. If you go to like the course website, you can see it here. So midterm exam 1, the solutions are here. But I will post it on NetStem so everyone knows. Good question. Yeah.
Then for I think homework project 3.
Yeah.
Do we come and meet you if you have questions on what we missed, or would you upload like usually
For homework 3,
for I think project. Like,
project 3, if you want to talk to me about what you missed, come talk to me during office hours. I can show you.
You
Yeah.
won't be uploading them next time.
Project 3 or part 3 or part 4?
Part 3. I think like what's in our grades? Like there is midterm, then you have to
I uploaded everything. Have you checked it recently?
Yeah, not the. I mean,
Huh?
I don't mean the scores.
What about it?
I mean like the correction. I don't mean the scores.
The corrections?
Like the correct thing.
For the project, there's no such thing as making corrections for it. Your grade is your grade.
So it's not like
I don't know what you're asking. Rephrase it and ask me again.